Alright, Alan here. Another cutting video. I know I said the last one was going to be the last cutting video, but I can't tell myself I have to try this 200,000th depth of cut just to see if it'll do it. And so that last cut was a little violent, and I mentioned in the previous video that it was actually, you can see, it was ramping down into the part on the climb cut on the second pass, and you can see that. And actually, I think what was happening was the TTS was actually, the Tormach tool holder was actually pulling out of the R8 collet that holds it in place. So that was kind of at the limit of the Tormach. Apparently, either that or I, didn't have it perfectly, mounted or something. I don't know, but it was pulling the TTS tool holder out basically on that last cut. So what I did was I swapped out. This is now in a R8 collet. It's a hard-inch, half-inch collet. So, and we're going to try the 200,000th depth of cut. I've got a couple pieces of high-speed tool steel underneath there that were actually lathe tool bits, blanks basically, just to prop it up enough so that I've got enough material to try a 200,000th depth of cut. I don't want to have it sticking up real high, and if I put a parallel under there, it's going to be sticking up too high. So, well, not too high, but higher than what I want. So that's the plan, and I backed off on the aggressiveness a little bit. I'm only going to do a conventional cut in both directions, I guess. I'm not sure why. That's what G-Wizard said, use conventional cutting. I'm not sure if that's right, but that's what I'm going to do, conventional cut. So it's going to cut, left to right, and then it's going to come up in the Z height, come back over and do the second pass left to right as well. And it's going to do 200,000th depth of cut, 7 inches per minute, 12 or 1100, I believe, RPM. So let me just check my code here. Yeah, 1100 RPM. So, and yeah, this is probably not a great idea, but let's just see what happens, I guess. Nothing ventured, nothing gained, or nothing ventured, nothing lost, depending on who you ask. So, better have my... Oh, this is scary. It's a high pucker factor. That's vibrating like crazy, dude. Oh, man. There goes a piece of aluminum. Wow. Whew. Wow, it actually quieted down a little bit. Okay, I'm impressed. That's pretty cool. That's pretty damn cool. Nice. Pretty cool. Well, let's see what the surface finish looks like. Yeah, there was a lot of chatter on that back pass. You can see the chatter. Of course, this isn't a roughing end mill either. It's a finishing end mill. So it's really not the right end mill for this type of cut. And then this front pass was a lot smoother. I guess that had something to do with the width of cut. Interesting. Well, it did it though. Yeah, it was 200,000 depth of cut for the new spindle. I guarantee you, man, there's no way you could do that in medium carbon steel with the Mikini spindle. There's just no freaking way. So that's pretty awesome. Alright, definitely done now. No more cutting videos. You know, if you want to see, you know, cutting in stainless or TI or something like that, you know, do your own conversion and knock yourself out. I'm pretty happy. I'm going to be cutting at 6061, so I don't really think I need anything. I don't think I need to prove anything else to myself, at least. So, all right. So thanks for watching, guys, and that's it for me.